Okay, now that we have some understanding of what a piecewise function is, let's take an example of one and learn how we can evaluate function values in a piecewise function. So here's a piecewise function. Here's the function f of x. It's defined into three pieces. The function value is x plus 3 when you're taking x values less than 0. The function value is x squared plus 1 for x values. Oop, this is written wrong, sorry. That should say 0 less than or equal to x less than 3. So when x is in this interval from 0 to 3, we're going to plug it into x squared plus 1. And we're going to plug into square root of x when x is greater than 3. Okay. So what we want to do is when we're evaluating function values, we'll take the domain value, the x value that we're plugging in, and we'll use that to figure out which piece of the function should I plug this number into. So I tend to liken this to like a toll booth where you're driving on the highway, whatever, you get off, and there's different lanes for different types of vehicles, right? Maybe if you're driving a tractor trailer, you have to be in this lane. If you have the good to go pass, you have to be in this lane. If you need to pay with cash, you have to be in that lane. And so as you approach the toll booth, you need to drive into the lane according to what type of vehicle that you're in, right? So you can think of your vehicle as the domain, and the toll booth is this piecewise function where you can only go into certain pieces of the function. Same idea here. If I'm the number -5, driving my -5 car, boop, 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 right? As I approach the toll booth, I have to pay attention to say, if I'm -5, which of these filters do I have to go through? -5 is less than 0. That's the only filter that I am allowed. That's the only lane that this guy is allowed to go into. So -5 has to drive in through this lane and go into the x plus 3 function. So when we evaluate f of -5, we're going to evaluate him in the x plus 3 function. So we'll do -5 plus 3. -5 plus 3 is -2. So this means we know that f of -5 is -2. Okay, so pick your domain value, or whatever domain value you're plugging in, come from the right to make the decision about which piece you should go into, right? So if we look at f of 0, okay, now I'm in the 0 car, right? So if x equals 0, then the 0 car has to look at these lanes and be careful here. It says the top lane is for cars that are greater than 0, for x values that are, less than, x values that are strictly less than 0. The middle lane is for 0 less than or equal to x. So 0 is included in this middle lane, so my 0 car has to go into the middle lane. So f of 0 is going to use the middle function. So I'll do 0 squared plus 1. Right, I have to do the middle lane since 0 has to go through the middle lane. I use that middle function. And then 0 squared plus 1 is just 1, so I know f of 0 is 1. Okay? And hopefully maybe now you're getting the hang of it and you can kind of recognize what you need to do. If you wanted to pause and try to evaluate these few ahead of me, go for it. As I look at f of 2, I can say, all right, I'm not in the 0 car, I'm in the 2 car anymore. If I look at 2, when x is 2, I need to go again. That's between 0 and 3, so I'm going to go into the middle lane. So I have to use the x squared plus 1 function. So f of 2 would be 2 squared plus 1, which equals 5. So f of 2 equals 5. And so forth, right? We're starting to get the hang of it. When x is 3, part D here says f of 3. So I'm in the 3 car. So be careful here. It says the middle lane is only for values that are less than 3. Values that are greater than 3 go into the bottom lane. And so this could happen occasionally. We're going to see functions that have these kinds of breaks in them. 3 can't go into the middle lane. It can't go into the bottom lane. In fact, this 3 can't go into the function at all. Now that analogy to the toll booth probably breaks down here because a car has to have some lane to go through. But in a mathematical function, all that means is that there's no place for 3 to go. In other words, there is no function value that corresponds to 3, or to x equals 3. So that just means that f of 3, we can't know what the function value is. There is no function value. We would say it's undefined. Okay. We're going to see some functions in this chapter a little bit maybe, and then more so as we continue into calculus, where there are breaks and there are discontinuities and there are function values that, or there are domain values, I should say there are x values that aren't defined for the function. And that's going to happen sometimes. So I just wanted to see that kind of weird case. That's not going to happen a lot, but just so you're aware, if it doesn't fit into any of the categories, then the function is undefined at that value. So the 3 car has to turn around and go home. Sorry, guy. Next, we're moving on to the 9 car. 9, we want f of 9. F of 9, 9 is not less than 3. It's not less than 0. It is greater than 3. So 9 has to go 9 has to go to the bottom lane. So 9, x equals 9 means we're going to use the bottom function, the square root function. So f of 9 is simply the square root of 9, which is 3. So that's how we evaluate function values on a piecewise function. Use the intervals on the right to decide which piece of function you should be using, and then just plug the x value in as usual.